has.
Thank you.
Yeah.
Good afternoon, everyone. It's a pleasure for me to be here and speak at Scala by the Bay about Scala and how we are starting realizing it's a very valid language to undergo serious data science work in the enterprise. So just a few words about me. So my name is Xavier. I'm a co-founder of Kansu, formerly known as Data Fellas when I had one partner. The other co-founder is Andy Petrella, who you might know, some of you. And when we were two, we were the fellas of data, mostly doing, irreverent speech talks at conferences. Now we are growing into a more respectable company, and we changed the name into something that is more, less gender specific, let's say. So we're quite kind of proud to be open to the world when we hire people. And so Andy is quite well known in the Spark community and Scala community for his contributions, and specifically for the Spark notebook. So a web UI, an interface to work pretty efficiently with Spark that is leveraging the Scala language specifically. And so with Andy, we've been doing a lot of work, either independently or where we joined our forces as a consultant in data. So we've seen a lot of things happening related to data science and how that work was conducted in different projects, be it in academics, where I spent a part of my time doing physics, bioinformatics, quantitative finance, or in geospatial projects, IoT. And the conclusion we had is distributed computing is very important. It's really the way to go, and the industry is proving it those days. But the way you do the traditional statistical and data science work is really hard today still to match this new environment. And that's why we started working on a product that is really aiming at having data science sustainable in the modern world of data. Just two things I want to mention. We are working with Alexi on a book, Scala for Spark, in production. Why in production? Because we believe that it is really the valid choice if you want to go in production in the enterprise to be on the JVM, and Scala is imposing itself as the right way to go with data science. We also, so this book should be in early release program, early access program within a couple of weeks, if we don't accumulate too much, if we don't get too late. Then we organized, So we also have with Aurélie a collaboration. So this workshop, this training on building distributed pipelines for data science, which are, I think, pretty cool, because you get to see working really easily with Docker containers, Kafka, Spark, Cassandra, some machine learning, generating service to create the stuff. So it's really amazing stuff. But I'm bragging too much here. Let's go to really the topic of this talk, which we really want to talk about data science today. And when we look at what happens in enterprise today, it's just the same work as usual. That means it's collecting data, exploring your data set, preparing it correctly, then doing the analytics work that is, traditional statistics or more advanced machine learning. But the environment and the nature and the kind of data you're working with is getting very different. And that's why the traditional BI tools that are pretty efficient to get, business-aware people very efficient at giving answers to their managers is not enough Today we need some other form of talents, people like you who know how to code, who know advanced mathematics and modeling of data to get more from the data. Okay, and they have to be able to do that not from an Excel sheet locally on their computer, but from huge data sets that are, in a distributed infrastructure. So that's the first thing today. We need scalability. We need to be able to work on big data sets, and we want to be able to do that in production, but as well in development. You don't want to discover an interesting feature on a sample of your data, because it might not be valid on the whole shebang. Okay? And also because more and more people get, knowledge of these advanced machine learning methods, we want to be able to apply these models in the distributed environment. So there's a need for exploring the data much more than before. And of course, your manager wants to go in production. That means the data science work that is in the end of, let's say, statistics people, so mathematicians, that may not be the most proficient in producing production quality software. They have to get along with teams, developing those applications with the right level of quality, and also in collaboration with the system guys, so engineers, DevOps. And that is the hard part. So going from having a model to having it in production can be a several weeks process, because everything has to be redeveloped. The library that the data science guy used in his favorite language is not available in the production platform, so you have to find ways to deal with this. And then there is another aspect, is that there's a shortage of talent in that area. There's a lot of work that is being expected to be done in the future and now, and it means you need people to do that. There are not so many of them. They're aware of that, so they ask for a lot of money. They change job often, and that is very, very painful, because managing code is quite easy. We have GitHub for that. Whatever you do in code, it's stored somewhere. It's possible to read. But with the data, it's different. Whatever you run on the data is not necessarily stored. So you don't know what is the history of the exploration of the data. How did the guy discover that this feature is interesting? You don't know that. And when he goes away, he goes with that. And so there's really a problem of retaining the knowledge on the data that is in the brain of these guys that costs a lot and move a lot. And so we need to find a way to share that work to be really sustainable in enterprise. Okay, so let's first focus on more technical aspects that really relate to Scala. So how do we do that work with Scala? What is the way to get scalability? And do we have the right machine learning methods to do that? So first, a few words about why Scala is a choice for us. And that leads to the JVM, the functional paradigm, the simplicity of the language, and actually its interactivity. So first, the JVM. It's very obvious that if you work in an enterprise world, you need a setup that is enterprise ready. And with more than 20 years of kind of approval from the industry of this setup, it's obviously a very, it's the platform of choice for your data science to run. Do you really want to introduce a new technology? Not that often in big industries, and especially if it's for running the lower level, that is almost the runtime level of your applications. And because of this approval and the number of developers, applications, and libraries that are being developed in the JVM, there's actually a lot of things to leverage and a lot of people to help. So the JVM is certainly the excellent choice for running your data science in the enterprise. Then it's the functional paradigm. Today, data is distributed more than ever. Gone is the day where you take the data of a sample of it, you model it on your laptop at home, and then come back with a report claiming, I got the clue to get money out of our data. Because you cannot get the entire data lake on your laptop. Data is distributed, you have to work with it there. That means any processing of the data you conceptualize has to be shipped on the data and more on each chunk of data distributed in your infrastructure. So that means you have to think in terms of functions on the data and not the data being processed close to you. And of course, you want to express that code in a way that is completely independent of that execution model or orchestration that, as a data scientist, you don't want to hear or know anything about, right? While, in my opinion, it's really good that you know that what's happening into partitions. Maybe you don't need to know the really intricate details and lose time on that. But the code shouldn't reflect what happens in those chunks of data, if possible. The simplicity, of course, the syntax shouldn't be a barrier. And when you look at Scala syntax, well, I really like the Scala syntax because it's really close to those scripting languages and Python, for example. It's as close to, so Python is as close to Java than Scala is close to Java. They're just on the right side of the edge, I would say. And Python and Scala are really close to each other. If you have a data scientist doing Python and is, completely against Java or the JVM, you show him Scala code and he's really fast into it. So that's a good way to get into this. And Scala is very powerful as a language, as we know. There are so many crazy features, and it's easy to work with interactively. So now I will get through some notebooks. So most of the presentation and the things I will show are actually available on GitHub. So there is this repository where we have a couple of notebooks that you can play with at home. You can make pull requests, add some stuff. It's very open, and we will be grateful to have some contributions. So I will get to the demo and have some help for the microphone. So who is familiar with the use of notebooks? Yeah, quite a few. The Spark notebook specifically? A little less, okay. So the Spark notebook actually was developed first by Andy, who using Spark got a bit frustrated, using the REPL for several reasons, including one that is pretty obvious. Right, you are working interactively with your data when you're in the command line, but how do you get access to the history of your work? What has been in the end really executed to get where you are? That is something that is frustrating. So getting in your hand something that is solid and that you can save for a reuse is not easy. Also, it's always good to annotate your work. When you're doing data science, you are very into exploration. It's good to be able to annotate your work, and working in a web page like in a notebook is really the way to go. And that's also a reason why these IPython and Jupyter notebooks are so popular. So this version of the notebook actually runs with a Scala REPL behind the scene instead of, for example, a Python REPL with a Spark context that is initialized for you. So you have direct access to Spark from your browser. So it works with a server, and from that server you have a browser, like a file browser, like you have here, with different notebooks, each notebook containing code organized in cell that you can ask to be executed in the REPL running behind the scene. So we start with the Y Scala notebook. So you see it's structured here as cells that are markup or code. I will get over this Scala notebook, so the audience is probably very familiar with Scala concept, so I don't need to spend 20 minutes on that, just getting through this in a few minutes, showing the features that are really the important ones in Scala and how they relate to data science work and other platforms of interest for data scientists. And here I'm naming, of course, Python and R. So a note about these notebooks. The first version of these notebooks were actually developed by Dean Wampler, who most of you must know from his books on Scala, and Andy, and I contributed lately as well. So let's get started. So why Scala for data science? And here I'm really pointing directly to Spark. And the reason I'm pointing to Spark is because this API as an API for processing data is really good. It's really matching the collection API, which itself is, taking its concept from the functional paradigm on collections, and so it's really to work with, and the execution model management of data in memory is really efficient as well. So it's one of our favorite choice for processing data, for processing distributed data. And when we think of Spark is actually written in Scala, and it has interfaces in R and Python. So why would you choose Scala over this interface? There's a first obvious reason to that, is that if you're closer to the language, if you want to implement something new, a new model, it always has to be implemented first in Scala, because then you need an interface from the other language on that new method. So you're just closer to the system, and also you don't usually in the enterprise, if you want to be efficient with going into production, you want to avoid mixing up too many languages, and you have less feature coming, or features in Python or R are coming later always, and you have less features. So Scala gives you much more power. And it allows to be closer to the production environment. And the key here is to say, yes, Scala is valid for the data scientist as well. Maybe they have a little learning curve to take, but they will just get better, and they want a lot of money. Yeah, they'll be on top of the stack, and that cannot be bad for them, right? Okay, so first, functional programming and objects. If you look at functional programming, it's really about immutability of values, functions with no side effect. Why do you want that? Because you're working with data that is distributed. You don't want states to be managed. You have to process things all over the place. You don't want to have a state that is a nightmare to deal with. You want to think in terms of small things that are well contained in a context. These functions, I give you parameters, you give me a value, that's it. Okay. And higher order functions, we'll see the collection API that you probably know. It's really good to say, I create a function and I send it to the data, and that's it. It's really a way to think that is really close to the way it should be executed. So you express your code in a way that is very, very close to what you want. Actually, I took in Scala after having worked several years in Java. deciding that the JVM was kind of game over for me, went into trying scripting language like Ruby. Then when I discovered Scala, I could re-implement many things in a pretty efficient way and with a way of thinking that is much more efficient, I think. So other languages, Python has a mixture of functional programming and object-oriented. The reason you want object-oriented is because you may have larger projects manipulating complex things with different teams. It's good to have libraries and domain objects to manipulate. You have an encapsulation of the behavior of your object. So it's important. It's not only functional. And so Python supports both, but not as efficiently as Scala. R is really much more functional than object-oriented. And Java has started some support for Lambda, so like a functional style, but it remains a bit cumbersome in some aspects. Another thing with Scala versus Java that was mentioned by some people is, of course, the inheritance model using traits, so mixing behaviors into a new class is really nice in Scala. Having these fields that are initialized in traits, implementations of functions, of methods in traits is very good. And when you compare to Java and the collection API, you have always these conversions between the notion of a stream and the collection. It can be really cumbersome to go from one to the other just because you want to use a functional paradigm. Okay, so this is a first little example. It's a bit silly. It's just a method to compute whether a number is a prime number. So here is the first execution of some code in the Spark notebook. I define a function and I hit Control Enter, and now in the REPL behind the scene, it has been executed, and I have access to this function of an integer returning a Boolean. And I do simple things with a collection. So I take the first 100 integer and I apply this function on each element. So creating a tuple where I have the number and its primality. Then I will group by the primality. It makes an iterator containing all the numbers that are prime numbers and another one with the numbers that are not prime, and I will count actually the number of such elements being prime or not prime. And it's a simple process, but it shows how it's simple to express things in a pretty interactive way. And when you develop on data, working with a notebook like that, with the wrapper, you take your data, you make a transformation, you get one step, you make another transformation, next step, and you just think in terms of small functions to apply to your data to get exactly the transformations you want, and in the end you get something that is maybe not really trivial, but that was quite easy to develop. So here you see we have 1/4 and not 1/3 of the numbers between 0 and 1 that are prime numbers. If we want to do that in Spark, we need to work with the Spark context. It's the gateway to your cluster. So you can define operations on your cluster. And what I say here is that I want to take those 100 numbers, I want to parallelize them, so ship them in the cluster, distribute them there, and then the operations are just the same. So it's exactly the same API, even though we're working with a different concept. One is a collection that is local on my computer. The other is something that is distributed, and it's a lazy collection. That means that up to that stage, nothing is executed. I'm just defining some transformation on the data. So I'm just saying on this data, you apply this function, then this function, then this function. They're wrapped together in an object that is shipped on the different nodes of your cluster, and they are only executed when I ask for results. So here when I do collect, I say, okay, the result you give me back here on the driver, and I want to see it as a local array. Of course, you have the same result. But you see that it's pretty easy to get into distributed computing. There is nothing in that code that points to something specific about the cluster, about the nodes, about the way data is split in chunks. It's just a collection API. And that's the power, of course, of functional programming. So what about the other languages? Well, the Python API is very, very, very close to the Scala API. You write Python code in Spark, it really looks like Scala code. R is a bit more tricky and cumbersome, and Java looks similar when you use lambdas, but some features are missing, and it's not that concise as in Scala. Scala remains on the top. So the REPL, Java, we don't need to talk about the REPL. It's not yet there. Someday it will come. R has a nice REPL, and Python have a nice REPL. So they're good competition, I would say, in terms of interface. The tuple syntax, it's something that is very valuable when dealing with data, because usually you have a set of records, and these records, they're just columns. So a number of things you want to manipulate with a type, and one column may be integer, another floats, another string, whatever. So it's good to be able to manipulate a bag of objects of different types. That's exactly what tuples are. And so, yeah, that code we've seen before, we use the tuples always. Okay. It's really a common use in big data to work with key value pairs. Do we have these features in other language? Yes, we have them in Python, although, of course, dynamically typed and not static types. R has tuple, but it's really much less convenient syntax to work with them. And Java, we don't really need to talk about that. It's really hard to work with the notion of tuple, so mixing in different types without creating a class is really hard. Okay, now pattern matching, of course. So in that case, we rewrite the same execution, but we leverage the fact that we know the structure of the result to decompose it, instantiate some variable, and extract the information of interest. That is something that you don't find in other languages easily. And it's actually very powerful as a developer to be able to, whatever the depth of the nested structure, you just get into your object, take the element you want, and reconstruct a new structure just in a single small simple one-liner that is actually very easy to read. That is incredibly powerful, of course. And then when we think of tuples and pattern matching, you take the two and you have case classes that are another way to group different types together within a structure, a named structure, and you can pattern match on case class, of course. So this is an example where we actually take, okay, I didn't execute that one. So I'm defining here a case class, so I want to group together a name, last name, and an age in a person, a class. Then I instantiate some of these objects, and I can pattern match, so instantiate a variable here pointing to this person and get access to the fields, and then do some transformation here. So here I take Dean and Andy, and I add 1 to their age. Okay. So do we have these regular, of course, regular expression? As I said, we don't have in other languages, and case classes. So being able to look into the structure of a class, we don't have in other languages. Only Scala provides it. Then there is type inference, and I can tell you that developing a data processing workflow, so transformations on data, having type inference is incredibly powerful because you don't have to know in advance what type of result you will have when you're working with one stage of your transformation, but the system will tell you what you got at this stage. So if you would develop that with Python, you would have at each stage to ask for output for example, the first 5 elements, look into the values to understand what you're dealing with. With Scala, the system is give you simply back, here in the end, I have a tuple with Boolean and an integer. So it tells you what you have in your hands, and maybe you don't even have to think about whether, well, you know whether your transformation is right or not, because you have the right type, and you know where you are always. So that is something that is very powerful. Of course, you never have that feedback in a language like Python and R, and Java is even more frustrating because, yes, it is statically typed, but you have to write explicitly the type of everything. So, and because you have no REPL, you never know what you have in your hands. You have to figure out on paper, I would say. Okay, and then you have other things that are very powerful with Scala. You can do, you know, list of integer, and the system for you will use the underlying primitive integer type. So it's optimizations that are very, very valuable to get the work done. And then, you know, you have this capacity to create DSLs, like you have here with the in Spark, the data frame API. So here I'm reading some data, so it's a list of airports. I read this. The schema of the data is inferred automatically from the data itself. So I have the name of the airport, I have the city, and I have more fields. You'll see that in a minute. Then I can ask to cache it, so it's a Spark thing to have things stored in memory so that I don't have to read the data on disk every time. It's just there in memory, so it's very optimal. And I show the data. I should have the data available here. No. I'm not sure why it doesn't display. Anyway. And then you can use this DSL, so DSL for doing fancy things. Like, I don't see the data. Why? Okay, for some reason there is no output showing, but what's important is the code here. So I have a list of airports, and I can do really just like SQL. That means, oh, I want to group by state and country and count the number of airports I have in each state and country, and order by the count and get this data. And so you have this DSL here that allows to point to columns when you're grouping, making your count, and making the order descending, pointing again to the column. And that is the kind of powerful things you get because it's Scala. Okay, and with dynamically typed language, you have actually the capacity to create some DSLs, and actually the Spark data frame API is directly inspired from the Pandas API, which is a Python API on data. So, you know, all this experience of Python data processing has its value, that's for sure, and it's good to take those features into Scala. It's possible, so it's a good thing. There are a few other things that I invite you to get through. Let's go into some of the negative aspects of Scala quickly. One of them is the fact that if you're working with R or Python, there is one good reason usually is the tools you have in your hands. The number of libraries is just enormous, so there's a catch-up to do on that. The JVM also has some issues that might appear in the other language as well, but for example, arrays are indexed with integers, so we're limited to billion. And in a world where you can have terabytes of RAM, it can be a bit frustrating. And there are inefficiencies in the JVM memory model. We all know that it can be painful to get garbage collection done properly or fast when you have many records. But there are projects like Tungsten that are trying to overcome this problem by representing data internally in memory in a much more efficient way. And also, when you work with the Scala REPL, you can have some really weird things like memory leaks, because it's a REPL, but each time you hit execution of a line or of a cell, you actually have to compile what has been executed in a new object and get it done. That means that previous lines where you may have instantiated variable with a lot of data in, if you re-instantiate those variables with the same name, actually you lose the access to that data, but it's still there. So there are sometimes some bad things to overcome. Okay, so that is for the language Scala itself. Now, the next thing that I want to, it's going to be fast. The next thing that I want to mention is that with Scala and JVM, I mentioned it already, there is this tooling. Do we have the right tools to work efficiently with data science? Well, the answer is not that good. So, for example, plotting is one of the great strengths of R or Python. You have this ggplot API, so you have a data set, you can plot it whatever you want in an easy way and get really nice plots easily. If you want to do that in Scala, you're kind of in a trouble. And also because so many things were implemented in Python and R, it can be frustrating to be in Scala or even to be on distributed computing, because all of this work has to be ported to Scala and distributed technologies. And because we actually also have access to so much computing power, it's also time to implement new models for Scala and distributed computing. And now we're going to the Spark notebook to look at what are the features of interest into that platform. So why Spark notebook? So the Spark notebook is open source, and it's really focusing on productivity in enterprise environment. It has many stars, 1,500 to date or more. It has quite an interesting number of participants on the GitHub channel, so you will always have support on it. We produced many notebooks of examples, so you can get started and see many things. So the interesting point here is that you're in a web page, and you can interact with that page the way you want. So here it's a silly example, but you see I'm just executing a cell in which I just say, okay, I want this HTML chunk to be incorporated in the page, and I change something. I change the style of the page here. So you can create really nice visual if you want. Second thing is multiple Spark contexts. That's one of the specifics of the Spark notebook. So you have a server, but each individual notebook you instantiate will have its own Spark context, its own new JVM. That means you can work with your own set of dependencies in a notebook, another set of dependencies in another notebook. You never have clashes. You can have several people working on the same server. They will never interfere with each other. They can connect to different clusters, one working local, one working in the cluster. So that's really efficient. And to show this,
1 minute.
1 minute left? Okay. So this, this shows you that you actually have several notebooks running, and they are each independent. So we'll get through this feature. I have 1 minute. That's sad. So configuration that you can do interactively. As mentioned, you can define dependencies. That means you can import anything, get it from Maven repository, and get it running on your notebook. One other interesting feature is side pane here. So any variable you instantiate is referenced here, and you can access to this its definition. So we're really trying to get something close to the R interface that is RStudio. So having code, what is executed, and a view of your data. Okay. And then the important thing with, as I said, is really plotting. And here I will just run an example. So I have a case class, and I generate some data here. So I have a list of data. And because it's Scala and it's evaluated, the system knows the type and can offer you different kind of representation of that data. Because if I have a list of integer, I know I can make a plot of it. If I have a list of strings, then I can show you a list, right? And so here, the options, because I have a list of case class that contain a number of elements, I can have a pivot or a list. Okay, so that is how it works. And when you go further along, you have graphs that are implemented. And all these features, just to make sure I end with that, all these features actually are implemented in Scala. Under the hood, you have, of course, some JavaScript running and some HTML, but the plotting API is just Scala. And you can actually extend these and create a new type of graph of plotting just by implementing the JavaScript and the Scala API. So I have no time. I could speak during 2 hours. Just to finish, there are some many libraries that are being developed today to do data science. That is machine learning. It can be MLlib, you have H2O, you have deep learning 4J. All these are compatible with Spark, with Scala interface API, so you're very powerful and you're in your language, and you can do many things. Okay. So one last thing about going to production and retaining and sharing work. Again, Scala is a leverage there, because when you have a notebook written in Scala, you can know from the compiler what data is being read, what data is being saved, what is the schema, how it is used. And if you collect that information, you know exactly what you want to know, what is being done on the data, and you can create a knowledge graph of all this information. That's exactly what we do at Kansu. Thank you for your attention and your passions. I would like to mention Andy and Dean once again, who made a good part of this work possible.